So we're good to go here. Okay, so welcome back for everybody. This is mobile application development. Last semester, I think I've had most of you. I know you were just with Mr. G last semester. You know, we kind of left off working through React applications and Node applications and kind of doing that full stack web development. This, I know you haven't necessarily done that, but this tends to really connect in where that fits in. So you'll kind of see there are some touch points where it's like, oh, okay, so we've kind of built an app that works with web, and now we want to kind of transition to building applications that work on mobile and work specifically on Android devices is where we're focused this semester. Okay, so that's where that's what we're going to be talking about is really building applications for Android. Next week, I'm not going to hand out all these this week. I'm going to hand out next week. I've got a tablet for everybody, so we'll be loaning those out. So that's kind of a plus of this class is you have a tablet to work with so that you can work efficiently. It is possible to use emulators to develop Android apps. They do require a bit of a resource hog. They're definitely a good thing to kind of play around and do, but they don't necessarily work for everybody, so that's part of why we provide these as a way to do your development. And basically the way it works is you can work and write your application, and you hit a little button in Android Studio, and it pops onto here, and then you can test it on the actual tablet. So you'll be getting one of these next week. Just a reminder that these are things you'll need to turn back at the end of the semester because we do reuse them, but you'll have a little tablet to work with this semester. So what we're covering this semester, we're going to be using Android Studio as our main IDE. We'll be working with Android and building Android apps, and the primary language we'll be working is something called Java. So that's kind of where we're coming in. It's worth noting, you know, if you look at kind of what you've covered so far, there's obviously some new things here, right, to start out with. You know, hey, there's a new language called Java. None of you here have probably ever programmed with Java. That's okay. It's something we're just kind of going to build in and work through. The good news is that Java is very, very similar to C#. So if you remember any of your C# from second semester, it's almost identical. Okay, so and for good reason, those languages are very, very similar. Okay, so you're not coming in completely blind, but there are some differences that we'll have to talk about where those differences separate and aren't necessarily the same in different areas. Okay, so Android is what we're doing. We're not focusing, and we're not going to talk anything about building iOS apps. That's a completely different topic and world, and that's not something I necessarily have a lot of experience with, nor is easy to get into because you have to have all iOS hardware to do it. You actually have to have an iOS laptop and an iOS phone, and the licenses and approval, it takes a bit to get into that world. The good news is with this setup is anybody can do it regardless of what operating system you're on. Whether you have a Mac computer, whether you have a Linux computer, whether you're a Windows computer, this software works. So that's the good news is all of this stuff is available regardless of what operating system you need. And you don't need permission from Google to do it. That's the other thing, right? Google can't. It's just like, oh, you have your own device, you can work on it. So the idea we'll be using is something called Android Studio. It is freely available. It's built on top of IntelliJ. IntelliJ's platform, they put out a bunch of different IDEs. So Android Studio is the one we will be using. There's also a popular one out there they have called IDEA is their main one. And that one actually primarily is used for Java development, just straight up Java development. Like you can build backend servers or work with Minecraft or anything else that's Java focused. As well as they even have a version of their IDE that works for building games with Unity, which I've used and had really good luck with. So that IntelliJ IDE that's at the base is really a dominant one in the industry if you're doing Java at all. So if you decide to go further and you're maybe doing Java development on the back end or with web development, you will be familiar with this IDE. So that's a good plus, okay? So that's ID we'll be using. Don't worry about downloading it yet. I'll get you the full instructions later today. So general overview of what we want to talk about today. I'm going to go over kind of the outline of the course as far as what we're going to cover and when we're going to cover it. I'm going to give you a brief history of Java and Android and some of the things that have gone through there. I really advise taking notes on that part. Okay, definitely if you don't have some notes to take notes out yet, definitely take some notes on that area of Java, Android. Expect that there will likely be a homework quiz on it. It's something that we're going to focus on. You know, it's going to tie in when we get to things next Tuesday when we kind of get into Java. Because that history really, part of why I want to talk about that history is it explains why things are similar to C++, C#, right? Where are those similarities? Where do those come from? And it also kind of explains like, okay, well, there's this idea called Java, and we're writing our Android apps in Java, but the Java we're writing for Android apps is not actually the Java that's official Java anymore. So there's a lot of interesting history there that is important to understand in order to learn the language as well as to be able to accurately look for documentation online and know what tutorials are saying and those kind of things. There's some gotchas there that you need to understand the history of Java itself a little bit and Android. Hey, Danny, can you dismiss that on his laptop or whatever is ringing? So we'll be talking a little bit about history, and then I'll briefly talk about something new called progressive web apps, which has been kind of a growing thing for the last 5 years, but has seen some major upticks and some major changes that are really important in the past 2 years. So it's something really important going forward. So we're going to spend a little bit of time talking about that this week to kind of get you familiar with that. The long story short with PWA is it's a way to take say a React application, a web application, and turn it into an Android application without writing a lot of code. It's amazing. It really is amazing. I'm going to talk a little bit about the Android API documentation, give you the links to where to find those docs. Keep those bookmarked. You'll want to refer to those a lot. We're going to talk about what our textbook is. There's not a textbook you got to buy, but there are some digital resources that we will be using. I'll get you set up with Perusal because a lot of the digital resources I'll be delivering through Perusal. So that's the way you'll need to get access to them. And then we'll get you to your install instructions about what you need to do to set up your environment. There's 2 documents there, one to kind of set up version control and all those parts, and there's another one for Java and Android and the kind of things that you need to set up there. Cool. So that's where we'll land, and that's where we'll start getting set up with Android Studio. So let's talk about what we're going to do. So I've broken this up into roughly 8 units. These are not all the same size, just to be clear. Some of these will be shorter, some of these will be longer. So the first thing we're going to talk about is progressive web apps. Plan is that'll be Friday and Monday. And that's really the end of that. We'll be doing that, talking about it a little bit because it's really important. We won't be spending a bunch of time there. So we'll be talking about progressive web apps. More like 2 days, not the whole week. Getting started with Android, we'll get into actually building Android apps and working with Java and figuring out the basics there. Once we've got a handle on the basics, I'm going to look at and kind of jump further in the textbook, and we're going to talk about how do we get data from the internet, okay? And that's really important because it allows us to tie our application code into a backend, right? Let's say we've got a REST API, we can make calls to it. So that's what we're going to be talking about there, is how do we communicate and get things from the internet, whether that be JSON data or pictures and things like that. So that's where we'll be talking about that. There's a number of things in here that are not in the textbook. So we will be going off the textbook at that point. We will be talking a little bit about some things that are textbook, but most of this content is not in the textbook. We'll then be also talking about something called Firebase, which a lot of Android apps are using. It's a really powerful tool, and it's actually a way to get around writing a backend for your application. It's kind of like having a backend for your application, but not having to write it. It's not as powerful as, say, Mongo and Node that we learned last semester, but it's a good way to get up and running, especially if you don't have that backend yet. Cool. So, like, if you do have a backend, it's definitely preferable usually to go what we'll talk about here in 3. But if you don't want to maintain a backend, then number 4 is there. The other benefit with Firebase is it can do something called real-time stuff. It's got built-in support for WebSockets, which you can do with Node, but you have to kind of write that code yourself. It kind of comes with it. So one of the really cool things that happens with Firebase is you can literally have things where I make a change on my device and immediately pops up on somebody else's device. Just magically. It's amazing. So we'll be talking about that a little bit. And I think that's mainly what we're going to use to build kind of our final projects. It's going to be that. We're going to then talk about activities and intents, which basically means talking about apps that have more than one screen, right? And all the things that go into that in terms of navigating and passing data around from screen to screen to screen. Okay. That's where we're going to spend probably most of the time, because at that point I can give you a larger project. Right? Up until that point, our things are going to have to be inherently a little bit small. So that's kind of where that lands. That's where we'll really go into figuring out what we're going to do for that final project. Next up, we'll talk about responsive layouts and resource files. We've kind of talked about how to do responsive, but with web applications. Doing responsive layouts is a little bit different when you're building native Android apps. So there's some other things, some kind of tools and procedures that we have to talk about. How do we do that? Because we don't have things like Flexbox. We have to use the tools that we do have, which are a little bit different. And then last thing up, we'll talk about theming and styling, which is kind of, in some ways, is a little bit like learning CSS, except that theming and styling in Android isn't actually CSS. It's their own kind of homebrew situation, homebrew setup, but it is similar to that. So we're going to kind of, at that point, should have kind of a working application. That's at the point where we can kind of make it look nicer. So that's the overall plan of where we're going to go. Okay. And that does mean jumping around a little bit in the textbook, but this has been kind of my feeling after running this a few times has been, oh, well, it would benefit us more going through this route rather than the order that the textbooks usually go in, especially since for most people here, this is your 4th or your 3rd semester. I think that makes more sense for us to kind of follow down in that pathway. So that's kind of an overview of what we'll be talking about and when. You know, things will fit in the calendar as we kind of figure things out and how long things take. But that's the kind of overview. All right, so let's talk about the language and kind of some history of Java as a language and where its roots come from. I'm going to turn off the So Java is the dominant language that we'll be working with this semester. Okay, it fits into something called the C family of languages. Commonly know this as the C family of languages. Sometimes includes other ones, but these are the main ones, and at least the ones that are important for the history. Okay, so Java came about around 1996, as you can kind of see on that slide. It was really a revolutionary thing at the time. You'll notice in there, kind of in between, just some history, you'll notice that C# kind of came about in 2002 after Java. So it does have the benefits of knowing a little bit about what happened with Java. And there's also some history here. Hey, something happened in 2020 with Java, namely that it was bought out by Oracle. So originally Java had been created by Sun Microsystems and was later bought out by Java. let me backtrack and talk a little bit about all the way back in what at this point feels like the distant past. So we've got this language called C. It was created at Bell Labs in 1972. At this point, that's almost 50 years, 50 years ago. So that may seem like, hey, why do we even want to talk about C? Well, C is pretty important. In fact, all of the three languages here, C, C++, Java, those three have really influenced the vast majority of programming languages that are out there and in use today. In some way, shape, or form, most of those have, and they've influenced nearly every developer as far as is doing any coding. There's very few coders that have never written Java in some way, shape, or form. So it's very likely that whoever you're working with has some level of Java background and is going to influence the way that they code. Okay, and so that history is really important. Okay, and especially working with other developers. So C is a pretty basic language. Okay, this was in the space in 1972. Was in that space where there were very few high-level languages. Right, there were very few high-level languages. Prior to that, things were what we would say assembly code and machine code, where you'd literally tell the processor do this and then do this and do this. We do opcodes, things like add and multiply. You have to get down to the very, very low levels. So C is in this early family of what we call high-level languages, which meant that we started with things like variables and assignment and if statements and loops, right? So like if I were to write some C code out, you would actually probably be able to read it. So let's say I have a very simple program here. Int sum, and actually let me make it right while I'm at it. So int and actually I do not remember. So 1, 2, okay. Sum int sum 0. Let me do a loop. And maybe I do so when we talk about very early C, maybe do a printf at the end here. Okay, so most, if not all, of that should look familiar to anybody who's not even ever programmed C. But that's C. This is valid C code. Okay. There are some nuances here, but this dates all the way back to C. Okay. So we're talking about integers. We're talking about arrays. We're talking about while loops, printing things to the screen. All this stuff dates all the way back to C, right? So this is where we get a lot of these language structures. I think at some point the C language added the for loop, and I think the plus equals and the plus plus eventually got in there, but I don't know that they were there initially, right? So we're kind of, this is kind of where things started. Right? The origins when we're talking about C. C is a language that on the one hand is 50 years old, on the other hand kind of lives on in the sense that this is very close to C++, C#, Java. This is a valid program in Java, as is. The only difference being the printf is a little bit different in Java. And the initialization, I think, is a little bit different. And even JavaScript, right? The main difference being in JavaScript that we don't give our variable types, right? But there's a lot of commonality there with other languages that we've written and used. Okay. C is still out there. 50 years later, it's still out there. There's still a lot of C code being written and being used. All the major operating systems, every single one of them is written in C. Windows is written in C. Linux is written in C. Mac is written in C. All of them are written in C. Okay. Because that's where it really shines, and that's where it's kind of found its niche, right? Is in the low-level systems operating level. There's even C code in the Android operating system, and if you want to get really down and gritty into the internals of the Android operating system, which is Linux underneath, by the way, it's worth learning a little bit of C. You want to get the maximum out of the performance, out of the hardware. So that's still something around. Most of us don't code in C anymore, but it still has a very similar syntax to our Java and our C++ code, or C# code, and our JavaScript code. It really set the kind of standard for a lot of these different languages, and they followed suit and kept that same syntax. Okay, with while loops and if statements, typing variables and things like that. C++ came around in 1985, as you see there. The main difference being is that C++ added classes. That was the big thing that made C and C++ different, is that it added classes. Now, there are other things that it did. So, for instance, C++ is where we get the keyword new and the keywords delete, right? So new is a way to create a new object. Delete is a way to delete an object or what do we call it? Free up the memory to take that memory back. One of the gotchas with both C and C++ is they were not managed memory. They were unmanaged memory. So anytime you stopped using a bit of memory, the operating system or the language or the runtime did not take that memory back. It would just be out there floating, and until you deleted it, it was still there, right? So that was one of the issues, is that you had to deal with managing your own memory and knowing when it needs to be deleted. Okay. One of the big things that's where Java changed. Java was the first language to really see what we call managed memory, where in most modern programming languages today, we don't have to tell the computer to free the memory up. We don't have to tell it we're done with this memory. It's back and ready to be used for something else. It just kind of happens automatically most of the time, right? So Java was the first language to really pioneer that. And that's something we see in JavaScript. It's something we see in Python. It's something we see in C#. Really has influenced everything going forward, because this is a really helpful thing to not have to remember to clean up my memory. The other thing that happens with memory in the C and C++ world is we have things called pointers. A pointer is, here's an address for an actual memory location. So I can say, oh, It's 500 bytes from the beginning of the memory block. Let me just go look at what's there. And I can manipulate that, and I can actually address memory using something called a pointer, which also led into this whole having to manage your own memory, because if you're managing your own, if you're having pointers, then you have to manage your own memory, right? So pointers in this address kind of lookup is also something that went away when Java comes along, right? So we went to manage memory, and we went away from pointers, which is where you see most modern languages have managed memory, and they don't have pointers. Right? What we have instead is something called a reference, and a reference tells us where is it roughly, but it's not, a reference is not where it is in memory, it's where it is in the reference table, right? So anytime you have an object in, say, JavaScript or Java or C#, you go look in that reference table, say, oh, I want object 5, and in that reference table, it knows where the actual address of it is, right? It will go follow that reference to get the memory address. Also in that table is what we call a ref count that says how many pieces of code are referencing this object. Okay, so if there's 2 or 3 things referencing that, well, okay, somebody's using that memory. When that ref code goes down to 0, nobody has access to that variable anymore, is where the object gets deleted. So that's kind of what's happening behind the scenes, is that reference table is what's managing, keeping track of who's using what memory and when does it need to be deleted. Okay, but also means that you have references instead of pointers. Okay, so that's a little bit of history, right? So other than that, when Java came around, basically the gist of it was like, so here the gist was, let's add classes, because classes are a really cool thing. Plus, let's fix some of the syntax weirdnesses with C++. So there are also some other syntax differences between C and C++, most of which kind of have taken over and gone forward. But Java came along and said, hey, there's some weird stuff that C++ is doing. Let's make a language that's easier to work with, a language in a runtime that's easier to work with than C++, because C++ is a huge pain in the butt, right? So we got managed memories. If you're taking notes, some of the things that we got in Java, we got managed memory. We've got references instead of pointers. We have C++ had an interesting feature called multiple inheritance. We got rid of multiple inheritance. So Java and everything from there on is single inheritance. You can only inherit from one class, not multiple classes. C# is the same way. So with getting rid of multiple inheritance, we added interfaces. There's this idea of an interface. So the idea is that you can inherit from one class, but multiple interfaces. So there's a distinction between a class and an interface that got introduced with Java and exists in other languages like C#. Okay, and it's basically a way around the multiple inheritance problem. Okay, so those are some things that happened there. Other things that happened, when we were doing things in C and C++, we did a lot of things with preprocessor macros. Those are gone. There are no preprocessor macros in Java. They do, however, exist in C#. C# does have macros. Java does not. Those are things that you probably hadn't touched and done very much with, honestly, in the C# class. But they are a worthwhile thing to know about. What else was in that list? Also, in terms of importing files, with the way that C# and C++ and C build, you would always, if you wanted to have code from another file, you would include the code from another file, which would literally, you would say include like x.cpp, and it would literally be, or x.h, and it would be copying the entire contents of that file basically into your file as far as it was concerned. Really expensive and made things really hard. Okay, so one of the things that Java did is said, well, this is weird. Let's stop doing those includes in the same way. What we do instead is let's import, right? Let's do an import instead. And so an import kind of says, hey, I want to use this class. I want to use code that's in another file, but we don't specify anymore the path to the file. We just say, here's the name of the class. You figure out where to find that class. Okay, so like your compiler figures out, okay, well that's in this folder, and it's generally things like maybe I have a class named view dot with view with a lowercase v dot main view, and so this would be located in a folder named view and the class file named main view, right? So generally speaking, when we're talking about our class names, we have a bunch of periods and whatnot that talks about the folder structure, and then the last, and those will be lowercase. The last one will have an uppercase letter. That will be the class file itself. Okay? So those are some things that changed, right? Those are some of the changes that occurred there. Again, the whole reason being is to try and make basically programming easier, right? The goal was to make it as easy to switch as possible. So to get people from C++ to Java, make that process easy. So the syntax is very, very similar with that intent, but also to just take away a bunch of features so that you have fewer bugs, right? That was the whole gist of it, right? So inherently, Java does not have a lot of features that C++ did as kind of guardrails or training wheels on there to help us. Okay. So they came out with that was very successful. Another huge thing that Java did that I might mention before I leave here is they actually made it such a way that you could write your code once and run it everywhere, which was a really novel thing at the time. Is you could build your code, you could compile it, and you get like some class files or a jar, and then you could ship that to any operating system and they could use it. You could use your Java application on Linux, on Windows, on Mac, and you only had to ship one copy of it. Now that meant you were shipping things like jars instead of shipping things like exes or SOs for Linux or things like that. You weren't shipping binaries, but you're shipping what we call bytecode, right? Which actually is something you may have heard about because C# borrowed that idea. So we ship bytecode instead so we can run it everywhere. That's really different because back C and C++, okay, I could write this code, I have to compile it, but when I compile it, I'm making it into specifically machine instructions, so it only runs on certain operating systems and certain hardware, right? So if I wanted to have a version of my app that works with AMD chips versus Intel chips, I might have to build two completely different versions of it. I might have, or let's say I wanted to run on ARM. I have to make a specific build for ARM and ship those binaries and make sure you get the right one. Same way with operating systems, right? If you want to build it for Linux or Windows or Mac, you can do that with the same code base, but you end up with different binaries and you have to oftentimes change the code from it every different version, right? So you're literally making different versions of the app for every different operating system, for every different CPU potential, for different CPUs, for things like, hey, we have these things called, we have 32-bit, maybe operating systems, 64-bit operating systems. So you still see out there where there's 64-bit builds and 32-bit builds, and before that we had 16-bit builds. And so you have to maintain and test all of these different versions of of the software not having one version that you can ship, right? And so Java really changed that game and said, okay, we'll write one, we'll compile it to bytecode instead of machine code, and that way the bytecode can run everywhere, right? Because it runs through something called a virtual machine. So Java code doesn't run on the actual hardware, it runs in a virtual machine, which is kind of like an emulator. So there's kind of a fake imaginary machine that Java code would run on, but doesn't actually exist, right? Which inherently means that Java code is always somewhat slower than these other things. C and C++, because they're compiling down to machine code, are more efficient than Java, right? So the big trade-off you're getting is that ability to kind of run it everywhere, okay? Again, at the time that they did that, that was the only technology that could do that, right? That's changed, obviously. So they were doing that. They were, because of the run everywhere thing and because of the ease of development that they added, it really took off, right? So for a time, Java was like the language. It was the language that everybody was writing and everybody was talking about and everybody was developing software to it. A lot of that software still exists to this day and still is being maintained by a variety of companies, okay? There's a lot of companies that really were doing this. And we were talking 96, so early 2000s is where Java really had its heyday, okay? Well, Microsoft comes and looks at this and they say, well, we really want a share of that. Like before that, the primary language to write code for Windows was C and C++. And they're like, well, we'd really like a version of this thing like Java that we can kind of call our own. And that's where C# came up. So C# is very similar, very, very similar to Java because it was supposed to be, but with a lot of differences. Now, I will say that in my mind, I think C# is a little bit closer to C++ than it is to Java in some ways. There are a lot of things where they said, okay, Java, you did some great things. We're going to copy that. We're going to do that exact same way. But we also disagree with some of the features you took out and some of the things you changed. And so we're going to allow you to do some things that you could do in C++ that you can't do in Java. Okay. I think that, Java really, personally, from my own opinion, I think that Java really had its heyday. I think Java's heyday is largely gone. I think the C# did a really, really good job of writing an amazing language and doing a good job of improving on everything that Java had done. So they put a lot more money into it, and I think they've ended up in a better place. So if I'm going to have a choice of writing programs in C# or Java today, I would always choose C# over Java, hands down. But such is life. We can't use C# on Android because more stuff in history. So as things go on, so Sun was the original developer of Java. In 2010, Oracle bought out Java, okay, which is kind of interesting, right? So if you know anything about Sun Microsystems, actually their main product that they sold was hardware. They're actually a hardware company. They sold mainframes and server hardware, right? They didn't sell very much in the way of consumer hardware, but that was their main dominant thing. As long as Java was out there, I think everybody had the right question asked, like, well, why is this company maintaining a programming language? Why are they maintaining this virtual machine, this thing called Java, and giving it away for free? I think everybody asked that. Because it was kind of a weird part in their portfolio. But it was something that they developed. And I think there's some business reasons why that happened, but large in part, it wasn't necessarily their primary product. Okay. There's some other things in that process that they worked on. Okay. There's another product in there that you may or may not have heard of called MySQL. Have you heard of MySQL? MySQL is a SQL database. It's traditionally been open source and freely available for people to use. Okay, good place for people to get started. Well, it's a database, SQL database. Okay, around 2010, Oracle comes in, says we want to buy Sun. Okay, what does Oracle make? Oracle makes databases. Like that's their primary product. Is they make a SQL database called Oracle. That's literally their product, is the Oracle database. Okay. Basically, the way I understand it is that there are a lot of companies using MySQL in combination with PHP to build and deploy websites, and they're like, well, we want a piece of that pie, right? So basically, the way I understand it is that Oracle bought Sun to buy MySQL, to get that and be under their umbrella. That's the way I understand it. Okay, which, because they bought all of Sun, they got Java in the process of that. So they are maintaining Java. They have been pushing out releases roughly every year. But honestly, since that 2010 buyout, I haven't followed Java very closely, just to be honest, right? It hasn't been my primary programming language in the past 10 years, other than to do things with Android, okay? But that history is important, right? So that's owned by Oracle now. All right, so let's talk a little bit about some other kind of maybe, so you have the understanding of kind of where it fits in terms of relationship to other languages. Let's talk about some of the history of Java itself. Okay, so in 1996, we get the first version of Java. Roughly 2 years after, so 1998, we've got what was called Java 1.2. Okay, so 1.2 is in theory a patch release. Turns out, you know, as new software comes out, there's always bugs. Java was not immune to that. There were a lot of bugs in the early versions of Java, and so they made some pretty drastic differences through 1.01 and 1.2. So Java 1.2 is popularly known as Java 2, okay? Because there were so many changes from 1.0 to 1.2, it's really known as Java 2. And you'll find that in the docs. If you're looking through the docs in Java, there are a number of places where they refer to Java 2. If you see that, they're talking about Java 1.2. That was kind of a gotcha for me when I was first learning Java. It's like, well, what is this Java 2 thing? Okay. With the histories, they kept going up with their major releases. Were actually like point releases. So the next major release of Java was 1.3, and then 1.4, and then 1.5. When 1.5 came around, they said, oh, we need to stop doing these point releases. We need to actually call these major releases because they are major releases. So as of 1.5, 1.5 is both known as 1.5 and as 5.0. Okay, so we have this kind of history. So like 8.0 is kind of, depending on who you ask, might be called 1.8 or it might be called 8.0. But the way we usually name these now is as that major version. So we've got Java 5, we've got 8.0, 17 is the version that just came out last year. So again, it's seeing a gradual increase. Java 5 was a really big deal. With Java 5, we got something called generics, which was the big change. Okay? Generics is a way to say, hey, I want to build an array or a collection or a list that contains this type of thing, right? So in Java 5, I got the ability to do things like, turn the screen back on, I can have, let's say, a list less than, and string greater than. I have a list of strings. That's what generics gave us, is we could have types like that, which is huge. It's a really big deal in order to have generics. We also have things like, hey, I want to have a map of strings to integers. It's a really big change for the Java world. It's really important, and in fact, it broke some of the code that I was writing at the time. Especially, I've been writing Java code for a very long time. Because I was writing Java code back in 2004, was when I first got into it. Actually, integer singular. So we've got this idea of generics, we've got this idea of collections. All of this happened in Java 5. Huge deal, really important. Okay. In fact, it harkens back to one of the things that I said earlier. In the Java, remember when it came out, decided to remove a lot of features that existed in C++. Okay? So up until 5.0, we didn't have this. But it existed in C++ long before that. Okay? In C++, this was known as templates. Works a little bit different in the world of C++, but it used that same syntax, where you use the less than and the greater sign as part of the type. Okay, so this was formerly known in C++ as templates. It's now known in Java as generics. In fact, C# kind of had to do the same thing, where initially when C# launched, it didn't have generics, and it later had to add them. So C# and Java both have generics now, but they're slightly different. They didn't take the same tactic when they implemented them. And there's a lot of reasons why, and things where there are differences there. But suffice to say, they're not the same. One of the things that happened with these generics in the Java world is Java wanted to kind of add it in without breaking any code that was out there already. So one of the things that they did is they said, well, the way these generics have to work, it kind of has to be backwards compatible to code that's been written before. So what happens actually in the compiler is when it compiles down, it takes all of these generic arguments, string, integer, etc., and turns that into object. So any generics that you see, and when the code is actually running, it's actually running as if the word object was there instead of the word string, which is a very weird thing and makes some things not work the way you would expect them to. It also means that things in Java, certain things that should be obvious and should seem like you could do, you can't. I can't have a list of ints because int is what we call a primitive type. It has to be an object. Okay. So those are some things we'll get into and we'll have to kind of deal with. Is going to make the code interesting. This is legal in C#. It is not legal in Java. So that's part of where those differences come in. You may have done a little bit of generics, I think, in C#. Maybe you touched a little bit when you did link and such, but that's a really, really important differences. And this is one of the biggest things that usually trips people up coming into the world of Java is the generics. Suffice to say. Okay, so those got introduced in 2004. A few years after that, Android kind of started this thing of rolling. Not everybody knew about it. It wasn't very well known at the time, but it started around 2008. Okay, and it worked off Java 5.0. Right, so Java 5.0 was the dominant version out there, and so in Android you can use Java 5.0 for sure. That's the base. In fact, Java 5 features and language features, all of that works on every Android device out there on the market. Not every Android device, now this is the weird thing, not every Android device out there on the market can support higher than Java 5. They're becoming more rare, but there are still devices out there that don't support, say, Java 6 or 7 or 8, etc. Okay. So one of the things that happened at this point is the version of Java that runs on Android is not really the version of Java that Oracle is maintaining. Okay, so if you're looking at the documentation coming out of Oracle today, you're going to get different information and different APIs for Java that don't necessarily work on Android, because the Java on Android is really different from the Java that Oracle's maintaining. Okay, so everybody clear with that? So it's roughly Java 5. Okay, is what we get. Things kept going. Originally, the version of remember I talked about there's the virtual machine that runs your code. So originally, the VM that runs our code on Android was known as the Dalvik VM. So if you see that term, that's what we're talking about. Dalvik is the virtual machine that was running on Android. What year did Oracle buy Java in? Do you remember? 2010. Okay. So around 2010, some things happened thereafter. Oracle bought it in 2010. Google was already starting to work on Android and starting to ship out devices. So around there, I can't remember what year it was, it might have been 2012 or so. Oracle actually sued Java, or Oracle actually sued Google because they were using some code in their virtual machine in this Dalvik VM that was borrowed from their virtual machine they are maintaining and shipping for Windows and such. They won, suffice it to say. I actually can't, or I can't remember. I think they won, if I remember right. I don't remember what the outcome of that was entirely, but I remember that it meant that Google had to remove that part of it. Well, in that process, they said, "Oh, this is a really big problem. We don't want to have a lawsuit like this again." So, throw out the entire VM and build it again from scratch, not using any code written by Oracle. Okay. So as of 5.0, there's a new Android virtual machine known as the Android Runtime, ART, which is built completely from scratch. So all of the devices that are really out there on the market, as long as it's 5.0 or higher, are all running on ART. They're not running on the Dalvik. They're running on ART. Just a point of importance. This usually doesn't come up too much when you're writing Android code, but it can. So just that's a thing to be wary of in terms of the hardware. If older devices are running on the Dalvik, and newer devices are running on the Android version. Okay. In 2014, Oracle, at that point, because it was Oracle, released, added something to Java known as the Stream API, which is actually really cool, but has a horrible name. Because there have always been things in Java called streams. Those date back to even the earliest days of Java. And the Stream API isn't have streams. The idea with the Stream API is it does a lot of things like what you find in LINQ from C#. It does a lot of those things when you're working with data. Or if you're coming from the JavaScript world, like Lodash, a lot of things that are available and you can use in Lodash or underscore, those are now part of something called the Stream API. They're completely different tactics of how they do it. Doesn't look anything like Lodash, but it's the same goal. So it's a lot of stuff working with collections. It's really, really helpful. The Stream API can take things that might be 100, 200 lines of code and smush them down to one. It's huge, okay? The good news is, as of today, as of where most of the market is today, most of the market does support Java 8. So there's a way to turn it on in Android, in our Android Studio projects, and we'll want to do that. I think actually today it's turned on by default when you create a new project, but it is super, super helpful. So actually most of the apps that we build today are not anymore based on Java 5, they're based on Java 8. We've gotten forward 3 versions. It only took a few years. But we're finally up to the point where we can reliably build things in Android using the Java 8 APIs. Unfortunately, we still can't do anything after that. So we're talking about version 9 through 17. Yeah, forget all that stuff that exists because you don't have access to it on Android. Maybe we will have it in another 5 years. So that's kind of where it stands. Cool. So as far as what we have access to in Android, every device has access to Java 5. Newer devices have access to Java 8. But we're going to make the assumption that all our devices have access to Java 8. All right, talking a little bit about the history of Android. Android's been released at this point continuously, about 1 release and 1 new version every year. Originally, they would nickname all of those or give a code name to all of those versions. So like if you go back to Android 4.4, that's known as KitKat. Then you've got Lollipop is 5.0, Marshmallow is 6, we got 7, Oreo, Pie. So traditionally, all of the versions of Android are actually known by suites. In fact, if you look at pictures of their headquarters in Sunnyvale, you'll see that they have all these structures out in front that look like these sweet treats. In fact, they commissioned sculptures inside of them. So there's like a Kit Kat sculpture, there's a lollipop sculpture, there's a marshmallow sculpture, you got Oreo, and eventually they got down to this and they said, ooh, maybe this is too much, and maybe we need to just go down the letters. So starting with Android 10, with the 10, they went down to just letters. So Q and R, S, etc. Which you might notice that K, L, M, and O, they're kind of doing that already, kind of alphabetically arranging them, but now they're just like, oh, we're going to stop giving them names. We're just going to give them letters. Today, when they came out today, large in part, people refer to the version of Android not by the nickname and not even by this letter. Largely, if you look at the documentation and discussion around Android, most people refer to it by the major version. So actually, usually we talk about Android 12, Android 11, Android 10, 9, 8, etc. That's actually the main thing that people talk about today. There are places in the code where you may find yourself writing those constants, because there actually are some global constants written into the Android platform, where if you want to say, hey, I want to check if this is KitKat or later, you literally write the word KitKat. Or you want to say it's lollipop or later, you may actually have to write lollipop instead of 5.0. So that's one thing to understand is you might actually see these codes somewhere in, you may see these codes at some point. If you're trying to do backwards compatibility, that's where those names come from. Is those names like KitKat are a name for that version. There's also a third thing you see in this table called the API level. Okay? The API level says what version of the API are you coding against. Okay, this is actually what we use. Okay, if we're saying what version or what version of Android device it is, the definitive number to go off of is the API level. I generally just forget that the other ones exist because they're not as useful as compared to the API level. In fact, as it works in Android, it's very easy to get the API level and check it and put if statements around it. It actually isn't possible to get either of these two things, right? So actually, usually you end up putting against this middle column, right? So right now, the latest version is 31, which was released last year. So in code, we largely refer to the API levels, online discussion, and largely defined and referred to by the version number. Just something to be aware of in terms of discussion. So latest version, this one came out in 2021, 2020, 2019. I think that the devices that I'm giving you, the tablets we have, when I booted it up today, it was on 10.0, but there was an update that just got applied on mine and should be applied on all of yours. So I think we're on Android 11 for the tablets that you guys are going to be using, which is great. So we can use some of the newer stuff and not have to deal with some weirdness that happened earlier in the timeline. There's a lot of changes, suffice to say, between 4.4 and 5.0, so I'm really glad I don't have to talk about this anymore. Anyway, so this is where we're going to be landing, is I believe our devices you should be getting on 11, they might, or either 11 or 2. There's a distribution number here. This isn't up to date because Google has stopped pushing updated numbers for this. They used to give out a survey saying, hey, here's approximately the percentage of devices on the marketplace that are using this version of Android. They don't publish that anymore. So I don't know what the current numbers are, but last we knew, 98% of that was KitKat. Right? So that's part of why I don't put anything before there, is because there's less than 2% on the market of things that were before that versus after. So, but it's an important thing to look at, and what Google says nowadays is it's better to use your own users and look at their numbers to determine what you want to target, because one of the things we have to do when we set up Android projects, we have to set a minimum and a maximum. We have to say this app is going to work on a minimum of this API level and a maximum of the current API level. So if we say, hey, we're targeting API 24, then this app has to work for 24 through 31, even if there aren't any 31 devices out there on the market, the 24 through 31. So you do have to pick that range. It does determine what you can do and what you can't do, and workarounds that you have to do based on where you're bridging. Like, so at certain versions, you have to do this, and then after that, you have to do it this way. And oftentimes, at least the way it works in the Android world, is usually find yourself implementing both. It's like, okay, I can implement the code for this and implement the code for that. It can be a bit of a gotcha. So one of the things we do try to do at the beginning of this is figure out where are we going to start that minimum version. And I think I need to go back and look at where I've set that, but I think last time when I ran it, we were up to 24. But I need to double check. What version is going to be the right version for us. So you'll have a number, that API level, that minimum API level, that's the one we're going to use for the entire semester. So the expectation is, okay, all your apps are X up to 31. So that's an important thing to do when you set things up. Anytime you set up an Android project, that's the first thing you have to figure out, is what is the minimum version that we're going to support, because it changes and influences everything you do. And in fact, when you create the project in Android Studio, you'll get a different project based on the number you choose as your minimum. Okay. So that's really important to pay attention to. Cool. Everybody kind of good with that? Largely what I say is usually if you're building a market, you can't touch everybody. There's a lot of cost to dealing with some of these older devices. So usually 90% is usually what I would target for as a developer, right? 90% of the devices on the market. Because there will always be devices that are very, very old on the market that are never going to leave. There may or may not be your customers. Okay, so that's a thing you have to kind of decide. The closer you put your minimum to real time, the current version, the less weirdness you have to deal with, but the fewer customers you have to get access to. So the question is, where does that lie? Okay. So as I kind of mentioned in the intro to this, there is a brand new thing out there called PWA, which we're going to talk about on Friday, known as Progressive Web Applications. And the idea, I think they really came on the scene. The first kind of articles I was able to find out about actually date back to 2015. So 2015 is when people kind of coined this term of progressive web app and started talking about it. But it's been something that's kind of been brewing in the background and slowly gaining traction as more development time has been put into it, as the APIs have been getting better. But the gist of it is, the idea is to say, well, maybe I can take these web applications that we're building, that are getting better and better, that we talked about how to build in third semester, and maybe I can take those web applications and turn them into actually mobile applications. Because, for instance, if you look at any of the G Suite products, say Google Docs or Excel and Gmail, you see, hey, the web clients are really full-blown applications. They're tantamount and close enough to something I would actually run on my desktop, or something I would run as a mobile app. So maybe we can just turn those into mobile apps, right? Maybe we don't need to maintain two different versions. Maybe you don't need to make a native Android app and a web application. So maybe I can just make a web application that can be installed like a mobile application, like a native application. So that's what's happening. Again, it started around 2015, but has really seen there's been some major things that have happened in the past 2 years that really put them on my radar, that meant like, oh, well, this is the way of the future. So honestly, just a heads up, the way my feeling is I think that this is going to replace most of what we're going to talk about this semester. Just one heads up, right? Because it means that you can literally write a React application that runs on your phone like a native application. What we're building this semester are native applications built in Java. But I think this is where things are going, so I want to make sure that I show you how to do that, how to take a React application and turn it into a PWA, so that you have that background, because that's probably where things are going to be in 5 years. I suspect that we will be writing very little in terms of writing Java and writing native applications for Android. Would probably be this instead. But so that's kind of what that's something I want to mention, and that's something we'll be kind of building on top of the issue tracker that you built last semester. So do be aware that on a Friday I'm going to ask you to crack out your project, your final project from last semester, and we're going to code a little bit more onto it, and then we're going to put it away. So Friday and Monday next week we'll do a little bit with that. Looking for documentation online. There's two main places where you can get the official documentation. You can either get the official docs, the official API docs from Oracle, or you can get them from Android. Okay. So here's the link as far as we're finding it under Oracle. It's under docs.oracle.com, and you can see the version 17 in here, Docs API. You can Google that if you just look for Java 17 API docs. That'll come up. It's a really good thing to bookmark. Actually, let me take a quick look. Let me pull it up just so you can see it and be familiar with what it looks like. So when you find the API docs, they'll look a little bit like this. What you see down here is all of the different packages in the Java API. Java API is all the things that you get for free just by working with Java. So there's a bazillion classes that you get. So if I were to look at something like, let me go down to Java Lang. Why am I not seeing Java Lang? Huh. Oh. There we go. Okay. So if you go into the packages, you'll kind of find, oh, they've renamed it to, okay, new naming conventions. So it's under job base now. Okay. So if I go to here, so these are modules. So you'll see all the different classes in here. You start with a module, you go down, and you can say, okay, so base is all the normal classes. That's the ones we care about. Within here, there's different packages. So Java.io, Java.lang, et cetera, et cetera, et cetera. So this is kind of how classes in Java are grouped. If I go into Java Lang, we'll then see the list of classes that are in that package. So all classes and interfaces, I can go down and let's say, hey, I want to find out how this Boolean class works. We can see up the top that it is a class. It's in the package lang in the module base. And we can see some things like, oh, it's got some static constants like false and true and type, and it's got some constructors. All of this stuff is really useful because it tells you all the properties that are on there, all the fields that are on there, all the constructors and methods, etc., that you can get access to, and it'll tell you like what do they do. So like if I look in here, it'll say, okay, I can pass in a value and it'll construct a Boolean from it. You will see some places in the docs, which I didn't expect this one here, but since we're deprecated. Java's been around long time. Remember 96? There are a good number of places in the Java API that are marked as deprecated. And you'll see this in the Android docs as well. Deprecated means that Oracle or Sun decided this is something you shouldn't use anymore, whether it be a field or a method or a property constructor in this case. They're saying don't use it anymore. It's still there, you still can use it, but if you use something that's deprecated, you'll see a warning in the IDE about it. And you may see a warning when you build it. Okay, it's saying, well, you shouldn't use this, A, because it's dangerous, or other reasons it causes problems. And the issue with deprecated is they're saying, we might remove this in the future. Don't use it, because we reserve the right to potentially move that. So anything that gets ever removed from Java goes through, first it gets marked deprecated, and then it gets marked removed. Mind you, I don't know any examples of something that got marked deprecated and then later removed. They're very few and far between, except for some certain things under threading. I think threading, there are a few things with threads that actually got removed. But it's very, very rare that things get marked deprecated and then following removed. So you can look at this. This is, I would say, that Java itself has it's probably the best documentation of any language out there. That is one thing that they got right, is they generated a lot of helpful documentation. Microsoft did not do that so well. When they wrote up and made C#, C# documentation is not as good as Java's. And most other languages, unfortunately, are not as good as Java's. Java's just, they put so many hours in there, I don't know how they made it work. Because I would say that the amount of hours that they spent maintaining the documentation was greater than the amount of time that they spent actually building in building Java. So these are amazing. Absolutely use them. Okay, so these are the official documentation for Java. As I said, that may or may not be correct. Okay, it is a place you can look. It is a place that will come up in your search results. But I would recommend going over here instead for all of your research needs. So Google maintains their own version of the API docs that are specific to Android. So these are the Android API docs instead of the Java API docs. And that will get you to how everything works. A few things to point out. There's a little tab thing over on the top right. Does everybody see that? Java Kotlin. because there are two main languages that you can program Android apps in now, Kotlin and Java. So make sure when you're browsing the documentation that you don't have it set over to Kotlin. Make sure you have it set over to Java so you're getting the correct information that applies for what we're doing. Cool? Because there are some nuances and some differences between the Kotlin API and the Java API, even though they both work with the JVM, the same JVM. Okay, so make sure you're there. Also in here, I think that we can go up to API level. There's a drop down here, and you can change what API level you're looking at. So let's say we want to develop for version 31. We could go look up there and see what it looks like. Or I could say, hey, I want to look at an older version of the docs. And I could go and say, oh, I'm going to switch that to 24. And now everything that you see from here is going to be under 24. That's an easy thing to miss as you're kind of navigating around here. It's easy to miss that this number matters, especially if you're Googling things and coming from a search engine here. This may or may not be what you expect. So definitely pay attention to make sure that that number is the actual version you're targeting. I would recommend keeping that at the highest version that you're targeting, not the lowest. So if we're targeting 24 to 31, I'm generally looking at the 31 docs because it will tell me about anything that's been deprecated between 24 and 31. If I'm just looking at 24, I won't know about anything that's been deprecated further in the timeline. Everybody good with that? So do be careful about what version of that you're looking at. Rel is where it started. So that's one thing to kind of watch in the docs. I would really definitely recommend bookmarking that. You'll be back here so many times this semester because those things are so helpful. All right. So that's the main place where you're going to go to find documentation on the Android APIs. Next up, I want to talk about what we're going to use as our textbook. So what we're using as our textbook this semester is called the Android Developer Fundamentals course. It's actually produced by the Google's own developer training team. So this course is created and maintained by Google. It's a few years old, and I feel like they haven't updated things as much as they should have, but it is maintained by Google Developers Training Team. So this is an official publicly available course. Okay. In terms of what's included in this course, you'll see that there's a few different parts, right? So you'll see in here course materials include, this is based on the Java programming language. There's some code labs, which are some lab assignments, and we'll be using some of those as your assignments in this course. There is a concept, what they call the concept reference chapters, and this is the main part of the textbook. So if I click on that, go over here, it's shipped as a Git book. This is our main textbook for this semester. If I tell you to go read lesson 0, 1.0, or 1.4, etc., that's where these things are coming from. I've gone ahead and taken all this thing down and added it over to Perusal, so these things will be actually posted on Perusal, but this is where all that came from. Okay, so large in part you'll be reading that on Perusal, but that's where our textbook came from, just so you know. So there's labs that are included there. There's reading and theory that goes with it. There's some slide decks that they have produced to go with that. I'm not going to use the slide decks. I have in previous years. I'm going to steer away from that. Partly just because the slide decks in some places are different than the actual reading material. And there's also some starter app code that they give you, because some of the labs do have you say, hey, pull down this project and update it, as well as some finished solution. This is, Android Studio's changed enough since they released this that I have my own version of the starter apps that's been updated to a more recent version of Android Studio. So when they ask you for the starter app code, use my starter. Don't use their starter. I think I have a link in my syllabus to my updated starter code. So that's all what's in there. Just looking at the units that are in there, a broad overview. It's 4 units. Getting started. There's a bunch about user experience, namely working with UIs, GUIs. My experience has been that largely people come into this knowing actually most of what's in GUIs. So that's usually the part that people just kind of get inherently. It's like, oh, we've done Windows Forms. It's basically the same thing. So that unit 2 is probably the easiest part of this. Number 3 talks about working in the background. This is where I basically have to replace the entire textbook because everything has changed in terms of the Android side of doing things in the background. So that's where we really jump off the track and go somewhere else. There's also some stuff about in Unit 4 about saving user data. Again, that's where everything's really changed, and I really changed what I teach there. So Units 3 and 4 kind of made sense 2 years ago. I don't really teach much of the material that's in Unit 3 and 4 anymore, just so we're clear about that. Cool. So we'll jump around a little bit because of all the things that have changed. But that's where we're starting with, and that's what our textbook is. Cool. On Tuesday we'll start with like lesson 1 of that. Where was I? Yeah. Okay. So some just general tips for success in this course. Always ask for help, even if you don't need for help. If you don't think you need help, ask for help. I'm here to help. I'm here to assist. I try to do what I can there. There are definitely cases where sometimes you may spend 2 hours and not get anywhere because of yada, yada, yada. Sometimes things are difficult. Ask for help. If you get stuck, ask for help. If you don't think you need help, ask for help. I always have things to point out and notice and things that I will notice about your application that you might not realize. I've been doing this for enough years that I see things that may not be immediately apparent in just a matter of seconds of looking. So ask for help. Next up, make sure you're reading doing the reading assignments. There are quite a few here. There's quite a bit of theory in this course, and you really do need that theory in order to be able to do the actual lab exercises. So definitely make sure you're taking the adequate time to get through those reading assignments and do the reading that is necessary. I'm changing how I'm doing things a little bit this semester. I think last semester I had the assignments on Perusal and I was grading them through Perusal. I will be posting things on Perusal this semester, but I will not be doing any grading based on your annotations on Perusal this time through. So I'm not going to be assigning a grade to the reading assignments on Perusal. I'm going to be going back to just homework quizzes this semester. So you will have some homework quizzes to complete on Inside Ranken versus what we did last semester, which is where we got rid of the quizzes and just did Perusal. So I'm going back to quizzes over Perusal grades. Cool. That's having done that a few years and kind of come to the conclusion that it's not as helpful as I would like it to be, and the feeling that when I give quizzes, people do actually go back and do the reading. So that's where I'm going with that, is we're going to go back to quizzes there. There's also going to be some assigned videos to watch in addition to reading material. Yep. Yes, the homework will be open notes. It will be open notes. There just won't be grades for the annotations anymore. So you can still do the annotations as discussions and places to ask questions and discuss amongst yourself. I'm just not going to give you a grade for it anymore. yeah, so the homework things, the homework quizzes will be open notes. So take whatever you want. There's just going to be a quiz. There's going to be some assigned videos. There are actually some things in the Android world right now that there isn't actually a written article for it, specifically in like Unit 7 when we talk about theming. There's actually a really great pair of talks that they gave at Google I/O conference, which actually completely rewrites the thinking that's traditionally been in there. So there are some cases where there are actually videos that are more up to date than the written material. So I will be giving you some videos, and I will also be giving you some written assignments. It will be a combination of those depending on what's the best resource, what's the best source for that particular information. Cool. So if there's videos, definitely watch those things. Read the documentation. I just gave you the link to the Android API docs. Absolutely have that open while you're coding. I always have that on a second screen, on a second monitor open, because I'm checking it constantly. Anytime I do stuff with Java or Android, I'm constantly checking those docs because there is so much useful information there. So I would really advise having that open and taking some time to read through it. It's also really helpful if you have time to make some projects, whether outside of class or for class, in addition to what we're actually doing, to explore some of the concepts more than I can do in the lab assignments. There's a lot more. This is a really big field. It's impossible to teach everything in one semester, and there are tons of things that you will learn if you take on your own project and try something and experiment beyond just what I'm able to teach. So I really recommend doing that. Keep them small, make them small experiments, but just definitely make some experiments to kind of try things out to see how they work. Okay. So let's look at the syllabus now. So we're going to go through what's there. That's where we're going to jump over to. It's about 2 o'clock, so this is what we're going to hit next, but I think I'm going to go ahead and take a quick break here. So let's go ahead and break, give people a chance to stretch their legs, and we'll come back at call it 2:20. So it's 2:20. If I can bring it back in. So we talked a little bit about some of the history of Android and Java, and give you some of the background there to kind of understand like where we're going and what we're doing, and what are the tools that we're going to be using. And now you have what textbook we're working off of. Where to find the API documentation. We want to try and talk about how we're going to run the class as far as the rules and procedures and all of that kind of rigmarole is what we're getting into today. So that's kind of the end of my main kind of mini lecture for today. So just talk about the history, and then we just get into the rote of like what are the things you need to know. Okay, so in terms of that, looking for the syllabus, you'll find the syllabus. I've uploaded a copy to Perusal, but the main official copy you'll find the main page. The course is right here under Classroom management, you'll find the link to the syllabus. So that's the place you'll find the, click on that, you'll come in here, and you can see what I've got on my screen. Okay, so general course information, again, this is AWD 1112. Name of the course is Mobile Application Development. This used to be called, I think, like Java Programming or Java Programming with Android. So there's been a recent rename. We just finally renamed it last year. Spring 22, we're meeting Monday to Friday, 12:35 to 4:25. I believe, as you already know, 80 course sessions we're meeting in this room. I'm Mr. Smith. I think everybody's familiar with that so far. My phone number's there, my email, my Discord name. Usually the easiest way to get a hold of me is through Discord. That's usually the way I respond to you the quickest. But if you need to get a hold of me through email, it's there as well, right? So those are the main kind of two ways I usually take contacts. This is my cell number, so if you need to text me, you can do that. But my Discord goes to my phone, so I get all the Discord messages on my phone as well. As far as office hours go, my office is, if you don't know, is up a floor. Down that way, it's in all of the IT offices. And I'm in there, my office hours are 9 to 12. So if you do need to get in touch with me outside of class hours, I'm generally here in the morning, and you can do that. Just text me or just message me on Discord ahead of time to know you want to set something up. Yes, I do definitely want you to log those, and let's talk about that. I've got a slide that we do need to talk about study groups, and so let's talk about it at that point. So that's the general contact info. As I've kind of said, we'll be using the Android Developer Fundamentals, specifically version 2 that's out there, and here's the links to all the pieces, right? So the course overview, which we kind of briefly looked at. There's a release notes link here, which will tell you about what have they changed recently and what changed from version 1 to version 2. There's a lesson plan that kind of tells you how they architected and how they go through it. There's the main textbook, which is where all the reading assignments and where all the theory is. There's a link to the code labs. So those are the assignments, the labs that we use for some of our labs this semester. There's a bunch of them, and there's roughly one per lesson. So like there's 1.1, 1.2, 1.3, 1.4, etc. So I will direct you to some of those labs throughout the semester as far as assignments that I want you to do and complete. So you'll find that information there. Other things in here, there is a series of video lectures that they did over this textbook. Unfortunately, they're from version 1, but if you do want to check those out, the playlist is linked here. It's not easy to find anymore because I think the playlist is unlisted. There's no link to it anymore, but should you want to go watch those videos, you can, and then the slides for version 2 can be found at that link as well in your own drive. Here is the updated starter code. It's over on GitHub. When it asks you to use starter code for an application, you want to pull it from here. I may copy that over for some of the projects that you do, but just be aware of that's one place that you can get updated projects. Cool. Some of them do need starter apps. Obviously, we're working through the AWD curriculum. And so the kind of the main objective where this fits in is, let's see here. So develop and troubleshoot, implement applications using object-oriented programming principles and fundamentals. That does apply to this semester because Java is an object-oriented language. So we will be doing a lot of object-oriented programming this semester, more than we did in third semester, because we did everything functionally, but we'll be doing object-oriented this semester. And I feel like there was something else in there. Yeah, so that's the main one. where we fit into the overarching curriculum is that one. We'll also be obviously using version control to get to manage our code. So, general course objectives for this semester. So course level student outcomes. We're going to be building Android apps that respond to events using Android Studio. So that's one part that we'll be doing. So we'll be doing event-driven programming with that, as you're kind of maybe should be familiar with. Windows Forms and JavaScript, it was the same idea. User clicks on a button, you make something happen, they type something into a field. Awesome. And they type in something in a field, and we respond to that event. We'll be dealing with a broad variety of user interface elements. So we've got things like text view, which is a label. We've got edit text, which are like text fields. We've got buttons. We've got image views. We've got spinners. Spinners are like drop downs. We've got recycler views, which are used to display lists of things, like a list of cards. So we'll be using a broad variety of widgets to build those Android apps. We'll be building Android apps that have multiple screens, as I kind of talked about. We'll be doing that in the later on with the activities and intents section. We'll be building Android apps that use themes and stylings, dimensions XML, colors XML, strings XML that store a lot of different resources. So we'll be going through that and adjusting sizes and trying to do some responsive design. We'll also be dealing with the database component, namely that will be where Firebase comes in. Traditionally, I would have taught that with Room or SQLite, but we'll be using Firebase in that place. And there's some objects and OOP type stuff that we have to do as we build out. And we'll also be looking at how do we communicate with web services. So that comes in, I think, in that third section where we're going to be talking about how do we communicate with the internet, namely talking to things like REST APIs. So that's kind of an overview of some things that we'll be talking about. In terms of the attendance rules, so let me kind of read off the first blip here. So the rules are basically the same as they were for spring. There's not really anything much new there. Students are expected to attend all scheduled course sessions. Students are also expected to arrive on time and remain for the duration of the course session. And students are responsible for monitoring their attendance record on Insight Ranken. I try to keep that up to date. I post that every day. Sometimes I make mistakes. Keep an eye. It's kind of your job to keep an eye on that, to catch me when I goof something up. Sometimes I accidentally put something in wrong, or sometimes I may have to take the attendance like 5 minutes before course starts and have to update it later, and so sometimes I forget to update it later and things like that. So just keep an eye on that to make sure that is accurate. The sooner we find those issues, the easier it is to fix them. So this is a seated course. This is not an online course. This is a seated course. All students in, as far as that's concerned, your maximum allowable absences is 6. If you go over 6 absences on that 7th absence, I will have to fill out a form that dismisses you from the course. There is a way to appeal that and try to stay in at that 7th absence, but that process can have a result. So try to definitely stay below 6. Ideally 3 or less is usually kind of where you want to be. Any canceled courses that we have for holidays, there's 3 holidays this semester. Those won't count as absences, obviously. We are doing tardies this semester. So tardies are if you miss less than 10 minutes of class, then it's considered a tardy. If it's more than that, it's considered an absence. So if you're here right on time at the beginning and you leave exactly at the end, like arrive 12:35 or before, and you leave exactly at 4:25 or after, then you're fine, right? But leaving early or arriving late can result in a tardy. Every 2 tardies that you get count as an absence. Just a reminder there. So let's say you have 2 tardies, and 1 absence, that would count as 2 absences. Students missing, if you miss more, as I said, if you miss more than 10 minutes of the course, you'll be marked absent. There are opportunities, should you be absent or whatever for the class, there are opportunities and arrangements that we can make to try and make up work and move schedule around if things come up. So if you're sick on a day, we may be able to move deadlines around, or we may be able to have you take that test. Or if you need to be out of town, we may need to be able to move an exam or a test earlier, to have you take it early or later, depending on kind of what makes sense and what works in your thing. So we will work around, if things come up, if you have vehicle trouble, if you have trouble if you're out sick, we'll make arrangements, right? So just communicate where you're at with those kind of things, and we'll try to make it work. You can find the general Ranken policies in the student handbook. There's a link here to get to the latest version of the student handbook, and it's also available on Instagram. We do have some IT department specific policies. So just a reminder of these. As far as things go, we don't allow any streaming videos, YouTube, sort channels, etc., unless it's for class. The bandwidth on our internet connection is limited, and it is shared by everybody in the IT department. So please don't be using it for things that are not for class or that would be distracting. So that includes not watching video game streamers, Twitch, things like that. And please keep that outside of the classroom. Okay. If there's YouTube videos that you're watching regarding the Android or stuff we're covering in class or things I've assigned you, absolutely you can watch those in class, but if it's not class related, don't be doing it in class. Okay. Video games are off limits, including cell phone games. If you have any of those, if you're going to do any of that stuff, again, do it in the hallway, because that tends to be distracting to other students around you. So please take that out of class if you're going to be playing games on break or whenever it may be. We do allow earbuds, so you can bring in earbuds, you can listen to music. I have no problem with that. I do ask that you keep it quiet enough that other people can't hear it that are standing around you. If we can hear your earbuds, it's probably too loud. We don't want over-the-ear headphones. We don't allow those. We do allow earbuds, but not over-the-ear headphones, mainly because we want to still be able to get a hold of you if something comes up, or it's like, hey, one person found this. I want to mention this to everybody so everybody's aware of it. But sometimes there's announcements and information that we want to be able to share with the rest of the class, and so it's a lot harder to get hold of you if you have your ears, some noise-canceling earphones and such. But I know that several people do work better with music, and that would be me included, so that's fine. As far as the ID department goes, dress shoes are part of the mandatory appearance code, so you do need to be wearing those at all times. I'm not going to read too much of that. It says dress shoes need to extend past the lower part of the calf. Oh, right. So generally speaking, and this doesn't come up too often, but basically like boots, usually not allowed. We want them to be shoes. That sometimes comes up in the winter months, but that is one of those rules there. So tennis shoes or athletic shoes are never allowed. Work boots are not allowed. Again, just dress shoes. Jewelry needs to be removed if it becomes a safety hazard. I don't think that's a problem for anybody in here, and usually safety hazards don't come up while we're programming. So that's largely a case, largely exists for the people doing hardware and working with electronics. That's not usually applying to us. For this semester, both for the IT department and student-wide, we are going to ask you to wear masks all semester. So that's regardless of whatever else happens in terms of politics and rules and vaccination status or all of that kind of stuff. masks are required on campus at all times, period. The only exception to being that if you're drinking or eating, then you can lower the mask. But other than that, masks need to be on. They need to cover your mouth and your nose fully. Okay. There's some tips in here, general, in terms of what to do or not to do. Just reminders for everybody. Generally, you do want masks that have 2 or more layers of washable, breathable fabric. We want to make sure, as I said, they completely cover the nose and the mouth, fit snugly against the sides of your face, and don't have gaps. Here they recommend nose wires. I don't generally do nose wires, to be honest, myself, but that is one of the things that the CDC recommends. I'm not going to fault you on not having a nose wire, but it does need to be covering your nose. Those are things that need to be walking for. Recommend staying away from materials that are hard to breathe through. The N95 masks are pretty thick. Anything that's got exhalation vents is usually a no. And, we're talking about, again, N95 is usually ones we stay away from. So, academic dishonesty. I wish this was not a case for our department, but this is one of those things that this is probably one of the things I have to deal with most with programmers is that, well, code's easy to copy. Don't be copying somebody else's code, right? So all the work that you turn in needs to be your own code. That's really, really important, both from a sense of learning the material, making sure that, your degree at the end means something, and cheating and plagiarism really can hamper you both within the semester and going forward, and please really don't do it. Okay. Cheating on any type of exam falls under academic dishonesty. Homework assignments, helping another student cheat is always that. Having access to exam keys and things like that is off limits. Plagiarism, whether it be from your own work that you've maybe done for another class or another assignment, or another person's work is considered plagiarism. Both of those can be, including plagiarizing yourself, or you can be plagiarizing other people. One important thing to mention, and I did mention this in third semester, it does come up sometimes in this semester as well, your designs that you create, whether they be UML diagrams or screen mockups and things like that, they're just as important as your code. They're just as important as your code. They influence your code. So plagiarism on a design is just as severe as plagiarism on your code. Just so we're clear. So those are individual assignments. If I give you something to, hey, make some screen mockups for this, make a UML diagram, an ERP diagram for those kind of things, that's your own work, and you should treat it just like you would treat code. Cool. Sometimes students are like, it's not as important, or it's not part of the assignment. Well, that's part of the assignment. Okay. Sharing code through Discord or other online services, I don't care how much it is always plagiarism. Period. If you're sharing code through that is plagiarism. It doesn't matter how much you shared. It doesn't matter if the other student copied it or not copied it. If it happens, it's plagiarism. Right. So don't be doing it. Researching threads on Stack Overflow is a fine thing. I do all sorts of research online. Professional developers do as well. Use it as a resource, but still don't copy code. That's the issue where people run into. It's like, well, there's a lot of code snippets and things available out there on Stack Overflow, and it can be very easy and very tempting to just like, oh, this person's like line or two of code, I'm just going to copy it and bring it in. That can easily be plagiarism very quickly, even if it's just a very small number of lines of code. Plagiarism still covers one line of code. Okay, that's especially true if you do anything with, say, regular expressions. Regular expressions, it's really easy to go, okay, this person wrote this really long expression that looks really weird. I don't understand it. I'm going to copy in that my code, but I don't understand what that code is doing. Do not do that. If you're copying code that you don't understand, you're definitely plagiarizing. You're definitely cheating. So it should be something. If you find some other code some code out there that's like, oh, this kind of works. What you do is you say, why does that work? Let me test it, every piece of it, until I get it working. What you're going to find is that your version and the solution that you end up is nearly always different than what you find on Stack Overflow. That's consistently what I find, is I consistently find, oh, there's some helpful information there that helps, but my application, my situation is different, so I'm going to do it this way instead of the way that they had written the code, and that's what you should be doing, which means that at the end of the day, you understand the code, right? You understand what's been written there if you go through that process. Cool? So, any work that's submitted that is a clear copy of stuff that's found online is definitely cheating. Any work that's submitted that's a clear copy of something by another student is definitely cheating, right? So those are the kind of things. Just mentioning as far as things go here, so any assignment that shows clear signs of cheating or plagiarism is going to be assigned a score of 0 for everybody involved. So if 2 or 3 people turn in the same code, everybody gets a 0 on that assignment. And it's not just 0 for the part that was plagiarized, it's 0 for the entire assignment, just so we're clear. If you're found plagiarizing on any assignment whatsoever, there's an automatic work ethic grade at B&M traditionally that goes along with that at the end of the semester. It does not meet if there's plagiarism involved. Second and third offenses often result in students being removed from the class or removed from the program. So it's definitely something we don't want to see you do in the first place, and if you do it a second time, can be major repercussions from it. Okay? Somebody have a handout? Okay. Cool. So, in terms of the assignments and the weighting of assignments, so you'll have some reading and some homework assignments. Again, those are mostly going to be quizzes. They'll be on Inside Ranken. Those are 30% of your grade. You'll have labs and final project. Those are going to make up 40% of the grade. And then we'll have some tests, both some hands-on tests and some written tests throughout the semester, and those will be worth 30% of your grade. So that's kind of the breakdown of how things are going to be weighted. Cool. Grade scales, same as usual. General expectation for students is that this is an 80-day class. If you look at the numbers there, 120 hours of reading and homework hours throughout the semester. That lands around about 2 hours per day. So for every class, for every class or session that we meet, you should be spending about at least 2 hours outside of class working on the material, reading, or working on labs or whatever. That's part of the expectations, right? So if we're meeting 5 days a week, you should be spending at least 10 hours a day out of class working on the material. Is that clear for everybody? That's really a suggested minimum. Some people work at a faster speed, some work at a slower speed. So to just recommend that's the minimum. For some people, that may be 4 hours a day, 4 or 6 hours a day. But at minimum, we do ask that you dedicate at least 2 hours at home every day. In shop time, we'll be doing projects and we'll be doing lecture like this. We're trying to keep the ratio at about, for every hour of lecture, it's about 3 hours of lab time. So that's how we want to try and balance the ratios, and we'll kind of see where that goes. In terms of late work, I do accept late work. there's my policy for this. If it comes up, this is where you can find it. So for reading assignments, I do expect you to complete them before the due date, so you're ready for in-class assignments. So any quizzes and stuff, those are generally things that I don't give extensions to the due date. Those are things I expect you to do in the days leading up to the due date, so plan accordingly. Oh, and I should take those things off because as I said, we're not going to be doing the annotations on labs. I do allow those up to a week late after their due date. I do, however, take a 10% penalty for each day they're late. I usually don't count weekends in that. I usually just count the weekdays. But 10% per day. It's worth mentioning, if I can't download it, if it's not been committed and pushed up to Git, I can't get it, I'm still going to mark it late. So even if you, let's say you did it on Monday but didn't actually turn it in until Wednesday, that's 2 days late as far as I'm concerned, right? So I go off the date that it's pushed and I'm able to actually read it, just so we're clear there. So hands-on tests must be uploaded on the day of the test. There's no late turn in for hands-on tests. They have to be turned in the date that they're due, the date of the test. Do make sure that before you leave for that day, that all of your code is committed and pushed. By being committed and pushed, there's a timestamp in Git that tells me when was it submitted. If it's not committed and pushed, I don't have that timestamp. I don't have the proof of when you submitted or when you worked on it. Cool. And a good way to check to make sure your tests get uploaded is to go to GitHub website. You can see the code that's currently pushed. If it's not there, if it says if it doesn't show up on the website, it's definitely not there. Okay, that's the go-to to make sure that I can get to it. Cool. So I'd recommend pushing it, checking the website before you leave that day, just to sort all those issues out. Sometimes I do get students who forget to push things, and it's like, well, what do we do now? Because you didn't turn it in on the day. Okay. I would really recommend you have a habit of committing your work multiple times a day, not just once a day, but multiple times a day. Anytime you hit a major or the minor milestone, definitely make a commit. You're like, hey, I just fixed this feature. I just finished this lab. I just finished even a part of the lab. Commit it, push it. Okay. It's really good to have your commits very small, and especially even just preparing yourself for the industry, it's really good to have small commits. And it's really good to have that thing focused so you can look at, here's what I'm about to commit, focused on a specific feature or specific bit of code you're working on. I'm going to assess your grade on the most recent submission before the due date. I really do, however, like to see your work in progress, right? So it's really helpful to me for you to have that history of committing code and seeing how you're working on it for a variety of reasons, and sometimes that does play into plagiarism things too. So committing your code is a really important thing. It's a really good habit to be in as an employee. It's also just a really good habit in terms of academic dishonesty and other things, right? It helps in a lot of ways if you can do that. Don't worry about turning in code early that's not working. I understand that. I know that students are always turning in work that's unfinished. I want to see your unfinished work, so don't worry about that. You'll find all of your assignments and updated information, all of that on Inside Ranken, so definitely be paying attention to that for your grades and your assignments, quizzes, attendance record, etc. We will be putting some reading assignments on Perusal, so if you haven't created your account yet, which I don't think you have one yet, Zach, we'll go out to perusal.com, but for everybody, the course code that you need to join is Smith, TNJ, TMJ89. So that's the code that you'll need to get into the course. Our assignments, all of the code that you submit will go through GitHub. Make sure that you're commit, as I kind of said already, do regular commits, make sure you're committing and pushing. Work for every day, whether it's done or not, definitely make sure you push all your code at the end of the day. So that way, it ensures you don't lose anything. It tells me that you were actually working on the code, that you're doing something for that day. If you don't have a commit for that day, then to me it looks like, well, you just kind of weren't in the chair, right? And actually that's how your employer is going to look at it too. Your employer looks at it, if the developer didn't submit any code for that, didn't put it in to get, they didn't do any work today. Just to be honest, right? That is the way the industry thinks, is if you don't push anything to get, then you didn't do anything that day. So make sure you're pushing something every day. Okay. And I'd much rather see your work in progress than one huge commit at the end of the project. You know, maybe you've been working on for something for 2 weeks and then you finally submit at the end. I don't like to see that, and your employers don't like to see that. So it's much better to submit it in small chunks as you're going on rather than waiting to the end. Cool. As I said, all the hands-on tests need to be uploaded by the due date. Make sure that it's uploaded by checking the reminder. If I can't download and run it, then it's not going to be completed, and it's going to be marked late. One very important note on here: we're going to be using a IDE called Android Studio for developing Android apps. It's a great little IDE, works really well. It has one major problem: you can't downgrade it. If you update Android Studio, you cannot downgrade it. Unfortunately, different versions of Android Studio are not compatible with each other. So let's say I have version 4 and you have version 4.1. I'm not going to be able to run your projects. Let me just say that ahead of time. I'm not going to be able to run your projects if we're not running the same version of Android Studio. I wish that wasn't the case, but it's been that case for years. So we need to make sure that everybody's on the same version of Android Studio, which means we're going to all install it on one day and then never update it throughout the semester. So if you think that you're running into a bug, you're thinking that bug is caused by a particular version of Android Studio, please do not update Android Studio. If Android Studio asks you, hey, there's a new version, say no. Okay. Please say no. Because there have been many cases where they've made significant changes in updates, where buttons have moved around or there's been incompatibilities from version to version. So I really recommend you don't update Android Studio. Cool. I wish there was a way to easily downgrade Android Studio, but there isn't. There is a way to reconfigure the project for what version of Android Studio it's supposed to be built against, but that doesn't always fix the issue. Cool? So that's just one thing to call out. Do not update your IDE. General college information. There is tutorial assistance, tutors and such available through the SEC oftentimes. Generally speaking, for this course, there's usually not a tutor, just so we're clear, because this is fourth semester. We generally don't have any, but the only people that could tutor are going to be in this classroom, are going to be in this room. And usually a lot of you at this point either have jobs or looking for jobs, and so it's usually not practical or easy to find a tutor. Suffice to say. Okay, so if you do have cases where you need some help, you need some assistance, ask your classmates, ask the people in the room. If there was going to be a tutor, it would be a person in the room anyway. Cool. You have everybody on Discord. You can message them and get in touch with people outside of classroom, and I'm generally available outside of class hours, but So there is an SEC. They can help you with your gen eds, but they're not. I know that they're not going to have a tutor for this class. Cool. Academic accommodations, if you do have them, if you do need them, go through the SEC. They'll get those things in writing and pass on any information for that to me. Career services, this is great people to get in contact. And you've got a job board. Definitely looking through that, because ideally, we want you to be working by the summer. Most of you, assuming you're graduating, we want you to be out there looking for a job, even if you're not graduating this semester. Be looking for a job in this semester, because it's a good time to be doing that in terms of forming relationships with employers and getting that ball rolling, getting the resume updated and portfolio and things like that. So definitely be in mind there. This is winter. Snow days do happen. They are rare, but they do sometimes happen where we cancel classes because of weather, whether it be ice or snow or sleet or whatever. The thing to understand with that is we don't announce those through the usual channels. We don't announce snow days through the news or whatnot. Those tickers, you won't see us listed under school cancellations. The only way to know about that thing is through our specific emergency system. So make sure that your subscription's updated on that Omni Alert system. That's how we'll send out notifications to say school was canceled. So it generally comes out as an email and a text message, if I remember right. But yeah, so that's how we notify people that their classes are canceled. Sometimes if I get that notification, I'll post it through Discord as well. But yeah, and you can get the full schedule for the course. It's still something I'm working on. You can get that through inside Ranken. Go back and go into the course. So under here, the second link down is the calendar. So that's the calendar for this semester and kind of giving our schedule. I'll be updating this and adding details as we go on and as things come out as far as what we're doing. So for today, we're on the first day of class, and we'll be going through policies and procedures here. When we get to the end of this, I'll have you start to install some of the software, and that'll be kind of the end of the day. Tomorrow we'll pick up and finish anything we didn't finish off today, and we'll finish installing that software. And tomorrow there's a reading assignment on Perusal that I want you to get started on, which is an intro to progressive web apps. Okay. So that's kind of the plan for tomorrow. Is we'll just kind of mainly try to get all of our software set up and things like that. On Friday, I'll be going through a lecture on PWAs, progressive web apps, and so I'll be going over the content that's in that intro to progressive web apps documentation, and we'll do a lab where we're going to convert our issue trackers up to be PWAs. So we'll take those down. You'll definitely need to pull that code down if you don't have it anymore. If you don't have it anymore on your computer, pull it down again when you get VS Code installed to do that. And then we'll kind of finish that up. We'll finish that lab up, I believe, on Tuesday. And then we're going to get started in with the Android stuff finish it up on Monday, start up with the Android and the Java stuff on Tuesday. So you can kind of look at that calendar and see what's coming. Cool. So that's kind of an overview of the calendar, how you submit work, late work. As far as submitting things through GitHub, I will be, I think last semester we didn't use GitHub Classroom. I think I had you create repos for everything. And I think the first and semester classes, we usually have, here's one coursework repo that we give out and say clone this and then do everything in there. So what I'm going to be doing this semester is kind of somewhere in between. We will be creating more than one repo as the course goes on. right? So we'll be creating repos for different assignments. I'll get you some more details out of there. I am going to be using the GitHub Classroom to issue those assignments. So you'll have a link to clone the repo for the assignment that it goes with, rather than creating a repo from scratch. For Node, it's really, really easy to just create the repo from scratch, and that's basically the easiest way to do it. With Android, sometimes it really helps to have a repo to start with some base code and some things set up, rather than having to create the repo from scratch. So that's largely what I will be doing, is giving you starter code for most of these projects. Cool? Or a starter project for most of these. So pay attention to what the repo is and how I want that submitted. Usually there'll be a GitHub Classroom assignment for those things. But it's really going to vary from assignment to assignment. Just to mention, there are some appearance standards on page 26 to 29. Definitely pay attention to take a look at that in the student handbook. I'm not going to read those off today because I think most people had them figured out last semester, so I'm not too worried about that. And they haven't changed from last semester to this semester, so the same as they've been. So if there are some issues, if there are some things we need to talk about and work through, then we'll talk about those things. But I think that large in part, I'll do that on an individual basis where it's needed. Just some reminders on COVID-19. COVID-19 is still going. It's, we're still in a pandemic. There's still issues. There's still precautions that we're taking. So as far as precautions that you need to be aware of, if you feel sick for any reason, you have symptoms of any kind, you've been exposed, somebody in your family's been exposed, or you test positive, in all of those cases, stay home. Even if it's not, you feel sick like you're sick with COVID, just stay home. If you're sick with anything, we'd rather have you stay home and attend online. Okay. Masks are, as I said, required at all times on campus, and that's going to be for the whole semester. Okay. Also, from my standpoint, you saw me sanitizing the wiping down the desk, so I'll be doing that between classes as well, because we have the morning class, the C# class in here before us. So if I don't get to it, there is a thing that there's some rags over here to wipe down. So just if I don't get to that, definitely I would recommend doing it yourself, just because, again, there's a class in here before, you don't want to get something from them. As far as that goes. We talked about face masks already, so I'm going to go ahead and go on the next. I do want to mention that face masks is something that comes under the work ethic policy, right? So that can be a work ethic if it's not covering your nose or not covering your mouth or not fitting suddenly. We will be using the same work ethic grading rubric that we use in the fall. There's some issues that I need to resolve with that, so I don't actually have access to the work ethic course right now. It didn't get copied, so I'm going to be sorting through that, and we can look at that tomorrow or Friday when I get it set up. But that's what we'll be using. It's the same as what we did in the fall. It's just not set up yet. Okay, study groups. You had a question about this, Cody, right? So you're definitely encouraged to form a study group. I really do encourage everybody to be in one. The study groups are going to be student-led as they need to be. I do recommend that you have no more than 3 students per study group. Large study groups tend to be unwieldy, and you tend to not get anything out of it. Largely, if it's larger than more than 3 people, then not everybody gets a chance to talk and ask questions and discuss, and it usually doesn't have its intended outcomes if it's more than 3. So I ask you to keep it at 3 or less. Okay. as far as the work ethic, just like last semester, you will be getting some points if you're part of a study group. I look at that as a way of if you've attended it regularly. So the way I grade that's a little bit different than what's on the point chart. So it's kind of, if I remember right, it's like I think I counted it as like 5 points if some students only attended like 1 or 2 meetings. Versus if they were consistently attending meetings and I have that record, like you're talking about recording the attendance, then I think I gave people 10 points all told for attending. It was 15 or 10 for attending all of that. So that's kind of how I weight that. I do need for you to get any credit for the study groups. I do need regular attendance. I would prefer that as an Excel spreadsheet, but it at least needs to be linked, at least needs to be posted on the Discord channel. There is a specific study group channel where I want the attendance information logged. So that gives me a way to go back to authenticate and know who's there and when, how are those things called. As far as forming study groups, generally speaking, you want to assign somebody as the facilitator, which is kind of running and managing the meeting and setting the schedule and things like that of how you're going to work through things. And you generally also want to have a recorder that's kind of taking notes and making note of some of the things you talked about and what you did. Cool. That's just some general recommendations. So I want to give you guys a few minutes to just kind of talk with your fellow students, see who wants to join a group and get some of those groups formed. I have a handout for this, and I'll be handing this out. It's a pair of 2 pages. It kind of says what are they and gives you some space to form a charter. So charter is kind of the rules and the policies that you're following of like, here's what we're going to be doing. We're going to be meeting on Fridays, or we're going to be meeting on Thursdays at this time. Start at this time, end at this time, and writing all those details so you kind of know what the expectations are. Cool. So if you want a copy of this, just come on up. I'll give a copy for. I've got. I think I printed out 6 because you really only need 1 per group per se. So give you some minutes to kind of talk about that. Talk to fellow students, see who wants to join the group. Hand out one copy. Nobody else. Only there's one or two there. Like, I mean, Mike and Josh and Zach. Well, I think Danny's schedule's a little busier, so we just didn't want to make that. So yeah, us three. Oh, you three. Okay, got it. Okay. If you want to do what you find out before. No. One of the things that I do need from that is that there's some kind of outlines and requirements on the first page. There's a second page that is right down the charter. I do need the second page filled out, then turn it back in. Okay. I just know a few people expressed an interest last semester to join a group, and it wasn't really clear on what to. Oh, who was in a group? But I think overall for the groups that we did have going, that it was a net positive for everybody involved. So. So you guys are kind of working through the. Oh, they sent that one away. Or I'll just. So just to mention for everybody else in the room, there's the info to get signed up on Perusal. If you're not working through forming the study group, go ahead and get signed up there. Well, Michael's, you can talk to Michael, he's the second chair now, if you want to see if he wants to form a group. Yeah. Okay. So if I can get everybody's attention for a bit, you guys can turn that in at the end of class. But I need to get everybody for a little bit. So I need to get everybody on Perusal. So go to perusal.com, join that course, use that code, and when you get in, you'll see a few assignments. So once you're in, you should see something like this, list assignments and library up at the top. And under assignments, you're going to see a few different things. Okay? So under assignments, there's the few assignments to look at for today. The syllabus is up there. Please we talked through it. Please take a review. You can review it here and put comments on it. There's also an assignment here called How to Use Perusal. Definitely take a look at that. That will give you some more instructions on where the UI, how the UI is laid out, and how to use the different parts. Basically, the gist of Perusal is it's a way to put collaborative annotations on the article as you're reading through. Like I can highlight some text in the linked reading assignment, and I can say, "Hello, class." And so the way this works, just a reminder, I've now put a comment on there, an annotation. Everybody in the class can see it, right? So you can put something out there, ask a question or stuff on the text, and I can see it. Anybody else in the class can see it. So it's a good way to communicate and kind of discuss the text and the reading that we have. Cool. So definitely take a look at that if you're, especially Zach, because you're new to this. So definitely take a look and read through that. Then under for today, there's two sets of instructions for getting your dev environment set up. So under here, there's one called setting up your dev environment. Go through and do this step by step. You'll have done most of the things already, but I want to go through and make sure that all those things are up to date. So like make sure you have the latest version of Notepad++ and Git installed and Tortoise Git. All those things you want to make sure your software is up to date on. And then the other thing for today is to go through the second set of instructions called install the Java SDK and Android Studio, and that will help you get the tools installed that you need for this semester. Cool. So that's really what I want you to do for the remainder of the semester is work through those assignments on Perusal. Okay. If you have any questions and you need to ping me, if I remember right, go back into here. I think I can at somebody. So for instance, let's say I'm going to at David. I can say at David Jen. And send a message, and then they will get a notification. So if for whatever reason you need to notify me or you want to get me into the conversation, you just put at Paul Smith, and that will send me a notification that I have received a message. So that's the gist of it. So go ahead and work through those instructions. Move today, and we'll kind of finish. There you go. Cool. The numbers, the purpose, the time commitment, some of the guidelines we laid out. All right, I'll look at that in a second. So I'm going to post sync of this in Discord.